Yeah, good morning, all. This is Dr. Praveen, Associate Professor, School of Computer Science and Artificial Intelligence in SR University. Today, I am going to explain ER model, entities, attributes, relationships, enhanced entity relational model in DBMS, Database Management System. So, now the main objective of today class, what is ER model? What is entity relational model? Why we learn entity relational model? Okay, actually the data models are three types. Earlier we have network model, right? A network model, and next hierarchical model, and the very important data model is the entity relational model. Okay, here we will discuss the entities and attributes and relationship between entity and attribute. See, now the introduction. Entity relationship model is a popular high-level conceptual data model. ER model is the best used for conceptual design of a database. Now, what is database? First of all, we will discuss. Database is nothing but a collection of interrelated files. Okay, what is file? File is a collection of records. We follow some hierarchy. The file is a collection of records. What is record? A record is a collection of attributes or collection of variables. Now, what is attribute? It is a collection of characters. The character is a collection of letters, right? So, this based on this hierarchy, we have to create the database. Database is nothing but a collection of interrelated files. So, now ER model is the best used for the conceptual design of database. Conceptual design means we have to construct a designing approach. Okay, before implementation, we create a design that is nothing but a blueprint of our model. And next, ER model describes data as entities, relationships, and attributes. See, now it will describe the what are the entities are there, how many types of entities. Now, why we learn entities and what is the attribute, how many types of attributes, and what are the relationships between one entity to another entity, right? And ER model is based on entities and their attributes, relationships among the entities. An entity which is a thing in the real world with an independent existence. You observe here, entity is a real world thing. Simply you called as entity is the real world thing, right? And for example, a particular person is the entity, car is the entity, house is entity, as well as employee is also entity, right? These are all the entity names. Okay, you observe here, entity is a real world thing. Like examples are person, car, house, and employee. Now here, this is the person, car, house, and employee. And next one is this is the entity relation diagram. Entities here, this is the symbolical representation is this is the entity, and this is also another entity, and these are properties of the attribute is nothing but a property of the entity. Now this entity contains the attribute 1, attribute 2, swan attribute n. So the second entity also contains the attribute 1 to attribute n. So for example, the car is the entity. Here we have a car is the entity. Now, car is a entity. Now, attribute, what are the attributes of car? That is the model or color, right? And next one is the number of seats, that is the number of that is availability. And next one, that is the car engine number. Now, these are all the attributes of the entity, right? So, now, attribute. What is attribute? Attribute describes property or characteristics of an entity. Attribute is a property of entity, right? What is a property? Coming to here, in our previous example, car is a entity. Now, attributes of the properties of the car is car model, car color, car engine number, and car capacity, whether it is pure petrol or diesel type of the car, right? These are all the characteristics of an entity. Now, these are the properties of the entity. For example, an employee entity may be described by the employee's name, age, address, salary, and job. A particular entity will have a value for each of its attribute. So now these are the different types of attributes are there: simple versus composite attribute, and single valued versus multi-valued attributes, stored versus derived attribute. Now this is the thing here. Attribute, this is the representation of attribute. This is the simple attribute or single valued attribute. Now this is the multi-valued attribute. Now, multi-valued attribute. Multi-valued means we have to take the more than one value. For example, phone number is the multi-valued attribute. Now, some person having more than one phone number, so that we stored the two the values, value one and value two. And next one is the composite attribute. The composite attribute is the address, address. Now the addresses are address 1, address 2, address 3. Like the street number. Now here we write the street, door number, and nearest to some location, and city, and these are all the composite attribute. And next one is the single valued versus multi-valued is completed. And next one is the key attribute. Now the next one is the key attribute. Key attribute means the key is nothing but a unique identification. Like your phone number is the key attribute, right? Your all ticket number as a student, your all ticket number is say a key attribute. And next one is the now your Aadhaar card number is the key attribute, your PAN number is key attribute, and next one is your mobile number is key attribute, as well as your account number is also key attribute. Now these are all the key attributes. And next one is the partial attribute. So this is not a full attribute. So next one is the derived attribute. Derived attribute is always depends on the other attribute. Other attribute. So now derived attribute is depends on the main attribute. So that is the derived attribute. Okay. Now these are all the types of attributes. Simply you remember the attribute is a property of the entity, or attribute is the characteristic of entity, right? So these are all the different types of attributes. And next one is the entity types and entity sets. So here we observe here. Now the first symbol is represented the this is the entity. Entity is represented with the rectangle. And next one, attribute is represented with the ellipse. And the relationship is between entities is represented the diamond symbol. And weak entities is represented double rectangle. And identifying relationship is the represented with the double diamond symbol. And next one, derived attribute is dotted ellipse. And next one is the composite attribute and multi-valued attribute. These are all the different symbols for creating the entities and entity sets. Now coming to this one, an entity type defines a category of objects that share the same attributes. It is like a blueprint or class in a programming. Entity type defines a category of objects, category of object, right? That shares the same attributes. It is like a blueprint or class in the programming. For example, student is an entity type with the attributes like roll number, name, branch, and batch. Already we discussed in previous slide, employee is the attribute, right? So as well as student is also an attribute, entity. So what are the properties? What are the attributes of the student? Roll number is the property, name is the property, branch is the property, and batch is the property. An entity set is a collection of similar types of entities. stored in a database at a particular point in time. For example, I want to take some examples, entities here. So now student is the entity, and branch is the, that is called department is the entity, and next one is the faculty is the entity, that is called employee is the entity, and the department is the entity. Now we have to combine all these for the developing and developing for a college website. So the entity set means we have to take the collection of entities, that is called the entity set is a collection of similar types of entities stored in a database at a particular point in time. So all students in a college, like student 1, student 2, like UG student, PG student, and next one is the professional student, like all students are the entities. So entities. So right, next one is the next one. These are the important points here. Now cardinality and modality. Okay, many to many relationship and one to one relationship, one to many relationship, many to one relationship. Now these are all the relationships among one entity to another entity. M is represented many, right? And one is represented single. So now this is the simple example for the entities types and entity set. And a relationship is an association among two entities. Now coming to here, employee works in department. Now the association among two entities, two or more entities. Now what are the entities here we describe? One is employee, another one is department. What are the attributes of this employee? Employee ID, employee name. And what are the attributes of the department? Department ID, department name, department location. So the relationship between these two entities works, simply called works. Employee works, right, in department. I want to take a small example. I have take one statement, that is Praveen works in CSC, CSC, and I want to write Praveen works in CSC since 2007. These are two other statements. Now, how can I write the entity relationship diagram? Now, for the first one, I want to write here. Praveen is an employee in SR University. Now the department is the CSC. Now here, name of the employee. This the relationship is the works. Okay. Now name. Sorry, this is the employee. Employee. Now the name is Praveen. Now the that is called the what are the attributes of the employee? Employee number, employee name, salary, and one more is the department. Now the department attributes, which contains the department name, department location, and department number. Department number, right? These are the three attributes of the department. Yeah. 1 second, please. Sorry to disturbance. Yeah. Now the first statement, Praveen works in CSC. That is written as a entity relationship diagram. Now employee employee is the entity, department is the entity. So the employee name is Praveen, right? Employee number is 3006, employee salary is something, employee department is the CSD. In department table, we have different department numbers are there, different department names are there. So now we have to establish a relationship between these two entities with some specific attribute, that is department number. So there is no department number, now the Praveen is not in the department. So when two or more entities are associated with each other, we have an instance of a relationship. A relationship relates two or more distinct entities with a specific meaning. It is represented by the diamond symbol. The diamond symbol is the work symbol. And next Example, Praveen works in CSC since 2007. Now, since is a associated attribute. Since is the associated attribute. Now here we mention the since is the associated attribute. Now so now we enter the value of this associated attribute is 2007. For example, the works on relationship in a which employee and project participate of the management of the relationship type in the employees and department. Suppose now I want to take one more example. Now, Razu is a student in CSC department. His works under the supervision of Praveen, under the supervision of the Praveen. The project name is the online management system. So now in this example, in this statement, we have four entities are there. Now Razu is the student. So student is one entity, some attributes are there. And next one is the Razu is belongs to CSC department. So department is the another entity. You observe here another entity. Now what are the attributes of the department? We have three attributes are there. That is department ID, department location, and department number. And his works under supervision of Praveen. The name is the Praveen. So faculty name is the Praveen. So what is the what is the what are the attributes of the employee? Now that is employee name and employee number, and next one is the employee number, and one more is the employee department and designation also. Right? These are the attributes of the department. Sorry, private employee. And next one, the project name. The project is assigned to RAS. So what is the project name? Project ID, project name, and project description. That is the timeline. Okay, these are all the four entities are related with the database. Okay, this is about the relationship and enhanced entity relationship model. So what is enhanced entity relationship model? The enhanced entity relation model is generally sufficient for traditional database applications. Okay, traditional database application. But more recent applications of database technology, example, CAD CAM, okay, and telecommunication, images and graphics, multimedia, data mining, and data warehousing, geographic information systems cry out for the richer model. So now here you observe here teacher learning to student, and now the management is managed learning models. The ER model, enhanced entity relation model, includes all the modeling concepts of the ER model. In addition, it includes the concepts of subclass and superclass and related concepts of specialization and generalization. So now first we learn the entity relation model, and next one is the enhanced entity relation model. So now coming to subclass, superclass, and inheritance. I think everyone knows the class. Now class is a collection of members and member functions. Okay, right? Now the subclass and superclass, we have uh, here some thing is some models, some models that entity type is used for the representing both the type of entity and entity set or collection of entities of the type that exist in the database. So now this diagram defining a new entity type from the existing entities type called the inheritance. So in inheritance, we have a different types of inheritances are there. That is the single inheritance, multiple inheritance, and hierarchical inheritance, right? Multi-level inheritance. So when we are creating a new class, this class is based on the superclass. So that is it is inherited some features or all features from the base class or superclass, simply called as a superclass. Okay, new entity type is called a subclass, and existing entity type is called the superclass. Simple, it is written as this is the superclass and this is the subclass. Okay, now the subclass inherited some features or all features of the superclass, right? Coming to this example, online shopping mall. Okay, now user is there and order, product, product category, payment, tracking details, cart. So user makes order, right? Order contains products and product as product category. Now user makes payments and user as a address and order as a tracking details and a product added to the cart. So now these are all the entities. So now the user, without user there is no payment. So without order there is no track. Without product there is no cart. So one is depends on other. So user, what are the attributes of the user id, name and email, and order number, order amount, order date is the properties of the order. Product details, product id, name, price, description, these are all the attributes of the product. And product category, cid, name, these two are the attributes of the product category. And payment method, amount, pid, these are all the attributes of the payment. Addresses also four attributes. Tracking details also three attributes. Cart also two attributes. So now here subclass and superclass. First you remember, first we create the superclass, and we create the subclass for to take some features or all features from the superclass. Now, inheritance, already we discussed. Inheritance is a concept to inherit some properties or all properties of the superclass. And next one, this is the specialization and generalization. It is very easy concept. Specialization is the process of defining a set of subclasses of an entity type, and the entity type is called as the superclass of the specialization. The set of subclasses that form specialization is defined based on some distinguishing characters of the entities in the superclass. So now you have a employee is the superclass. Observe here, employee is the superclass. Now we have two types of employees. One is hourly employee, another one is the contract employee. Now every employee having some own attributes. Hourly employee having hourly wages and hourly work. Contract employee having expiry date, but hourly employee having employee ID, employee name. So same way, contract employee also contain the employee ID and employee name. So now the specialization means we have to create the set of subclasses that form a specialization is defined based on some distinguished characters of the entities of the superclass. Okay, now these two entities, hourly employee and contract employee, these two are inherited two features from the employee, that is employee ID and employee name. So specialized, we create a subclasses, okay, based on the superclass. And generalization is a reverse process of abstraction in which the with superclass. Now we have to create the superclass based on the subclasses. What are the subclasses we have? Sub entities are there. That is the hourly employee and contract employee. Now which contains the employee ID, employee name, hourly wages, and hourly worked. Contract employee also contains the employee ID, name, and expiry date. So now these are the two. These are the see observe. These are the two classes. So now based on these two classes, we have to create a new class from say, here what are the attributes? Four attributes are there. Here what are the attributes? We have three attributes are there. Now common attributes. What are the common attributes of these two classes or these two entities? Employee ID, employee name. So based on these two attributes, we extract these two attributes and create a new class that is called the superclass. So generalization is the reverse process of abstraction in which we suppress the difference among several entity types, identify their common features. What are the common features here? That is employee ID, and name, employee ID, name. These are all the features of this one. Here also employee ID and employee name. So now we have to take the common feature, these two common features and these two common features. Based on this one, we have to generalize them into a single superclass that is called employee. Okay, entity types are special subclasses. This is the specialization and super generalization. You remember one point here. Specialization means we create subclasses based on the superclass, right? And generalization is a reverse of the specialization. That is the we create a superclass based on subclass features. So say if you have a same features, we extract that features and we create a new class. This is the specialization and generalization. Now coming to outcome of this concept. So understanding the concept of entity, recognize the real world objects as entity in the database context. So, entity is a real world object, real world thing, and identify, define the attributes. Now we have a different attribute. Attribute is a property of the entity, right? We have different attributes are there. That is simple, composite, derived, multi-valued, and key attribute. And establish relationships, understanding how entities are related and representing those ER diagrams. Okay, actually relationships are one-to-one model, one-to-many model, many to one model, and many to many model. Now apply the ER model. Use ER diagrams to design a conceptual database scheme with appropriate cardinalities and constraints. Okay, and use enhanced ER model. Okay, after this one we can increase the ER models by using the enhanced ER model. And next one, develop real world scenarios, convert real world life situations into ER diagrams using proper designing technique. This is the ER models, and next we will see the what are the concepts remaining we have in this one. We have a key attributes. I will explain key attributes. Right. See, in relation model already we completed. So relation model, this is the relation model. Relation model in we have to create a entity. Now based on entity, we go to the logical design. The logical design, we create the table with some attributes that is called student contains roll number, name, and department. So now these are all the fields of the roll number 101 and some name and computer science and 265. This is the data in this table, student relation in relation model. Relational database is a collection of one or more relations where each relation is a table with rows and columns. Okay, the rows and column combination of rows and columns is called the table. This simple tabular representation enables even noise users understand the contents of the database, and it permits the use of the simple high level language to query the database. So now here you observe here, we will discuss the key constraints. Roll number is 101 and here roll number is 265. Suppose I want to enter roll number is again 265, that won't take because we specify roll number as a key constraint. Key constraint. So this is a relational model. Degree of relation is the number of attributes in its relation in schema. Now roll number, name, department. This is called the schema. Okay, and schema is nothing but a physical structure of the table. The degree of the relation. What is the a student? What is the degree of the student? So now how many attributes are there? How many attributes are there? Three attributes are there. Now, this is the cardinality of the relation is the number of tuples in the relation. Number of tuples. So, okay, how many tuples are there? Coming to this example, 3 plus 3, 6 plus 7. Now, so this table, the cardinality is the 7. Degree is the 3, right? And characteristics of the relation. A tuple is a set of values. A relation is a set of tuples. Set of tuple is nothing but a tuple is the record, and a relation is a file. Since a relation is a set, there is no ordering of the relation. The order of the attributes and their values within the relation is not important as long as the corresponding between attributes and values maintained. Each value is in tuple is a atomic, right? So that is the unique. And now integrity constraints. So in already we discussed key constraints. So an integrity constraint is a condition specified on database schema and restricts the data that can be stored in an instance of the database. So in database instance satisfy all the integrity constraints specified on the database schema. It is a legal instance. Okay, database DBMS permits only legal instances to be stored in the database. So types of constraints: domain constraints, key constraint, entity integrity constraints, referential integrity, and foreign keys. Okay, domain constraints. Key constraints is the very important. In our previous model, roll number is the key constraint. Okay, domain constraints is a relation schema specify the domain of each field in the relation schema. Okay, now not null, unique, and check constraints. These are all the domain constraints. Okay, and next one, key constraints. That is the constraints ensure correctness and validity of the data. So primary key constraints are the primary key is a must be unique and not null, right? And referential integrity constraints, foreign key must match with the primary key in another table. Okay, we have take the parent table and child table. In child table, the entity is the for references with the parent table attribute. So in parent table, that attribute is the primary key attribute. So child table, that attribute is the foreign key attribute. So now you have to we have one activity in a bank database. What would be the primary key in the account table, and what about the foreign key in the transaction table? So simple it is. In account table, that is the account number is the primary key. Coming to transaction table, account number is the foreign key. So this account number is references with the account table account number. So and start with the real time analogy. You have to analyze this. You may imagine the college database. Can two students have the same room number? Tell me. Can two students have the same roll number? No, it's not correct, because the roll number must be a unique and not null. So that is called the primary key. And department ID referencing the department table. So department table department number is the primary key, and student table department number is the foreign key. So this department number is references with the department table department number. Okay. Constraints already we discussed primary key and foreign key. Now coming to this example, now ID is the primary key. Here ID is the foreign key. When we enter ID in this table, department table, this is references with the student table, department number. Now these are all the referential integrity constraints. Foreign keys already we next we will discuss these concepts, right? And understanding the concept of the today class is now what is a AR model, what are the attributes, what is the relationship, and what is the primary key constraints, what are the constraints we have, how to apply the constraint. Thank you all. Thank you for your cooperation. Okay, please like and subscribe this video and share to your friends.